Good morning, students. Today we are going to see the topic distance and displacement. The first one, distance. Distance is the total length of the path travel. The definition of distance is the actual path of the length traveled by an object in the given interval of time during the motion. It is a positive scalar quantity. Scalar means only magnitude. The next one, displacement. Displacement is the shortest distance from the initial to final position. The definition of displacement is the difference between the initial and final position of the object in a given interval of time. It is a vector quantity. Vector means both magnitude and direction. The next one, example of displacement. Let us consider a car moving a straight line from the point A in a northward direction towards the point B, which is 100 meter away when the car reaches the point B. It is changed the position from A to B. In this case, the displacement is 100 meter. The displacement is vector quantity. So, we should also give the direction of displacement. The displacement of the car is 100 meter north direction. The next example, difference between the distance and displacement. Let us consider a car traveling a point A on a longer curved path of 200 meters and reach the point B. In this case, the displacement is still the same, 100 meter north from A to B. But the distance, which is length of road that a car travels from A to B, had become 200 meters. The another example is the car began the point at A, move 100 meter north, takes right turn and move 100 meter east, takes right turn and move 100 meter south, takes right turn and move 100 meter west and come back to the point A. In this case, even though the car traveled through the distance 400 meter, the displacement is 0 because initial and final position is same. Therefore, the displacement is 0. The diagram is the difference between the distance and displacement. The next one, displacement vector in Cartesian coordinate system. Let us consider a particle moving from a point P1 to a point P2. The position vector R1 vector is equal to x1 of x1 I cap plus y1 j cap plus z1 k cap. Another position vector R2 vector is equal to x2 I cap plus y2 j cap plus z2 k cap. The displacement vector, the displacement means small minimum distance or shortest distance. The definition of displacement is the difference between the initial and final position. Therefore, the displacement vector is del r is equal to del r vector is equal to r2 vector minus of r1 vector. Therefore, the displacement vector is equal to x2 of I plus y2 of j cap plus z2 of k cap minus of x1 of I cap plus y1 of j cap plus z1 of k cap. Therefore, we arrange this equation. Therefore, del r vector is equal to x2 minus of x1 I cap plus y2 minus of y1 j cap plus z2 minus of z1 into k cap. The next one, differential calculus. The first one, in the concept of a function. Any physical quantity is represented by a function in mathematics. Take the example of temperature T. We know that the temperature of the surrounding is changing throughout the day. It increases till noon and decreases in the evening. At any time, T is a small t, the temperature capital T has a unique value. Mathematically, the variation represented by T of T. It should be called temperature as a function of time. It implies the value of T is given the function T of T. The another example, the position of a car in motion along the x direction can be represented by x of t. This is called x as the function of time. Here x denote x coordinates. Differentiation important role in physics because it measures rate of change. First one change, second one rate. Now first talk about change. Quantities there are two types. One is constant, another one is variable. We use for del means big change, d for small change. Del x means big change in x. Then dx means small change in x. D is not a letter, it is an operator. We can not separate d and x. For example, let us consider the example f of x is equal to x square. Sometimes it is also represented y is equal to x square. Y is the function of x. Y depends on x. Therefore, x is independent variable and y is equal to dependent variable. Therefore, y is equal to x square. Y is the function. The function is a square of x. It means x change, y also change. Once a physical quantity is represented by a function, one can study the variation of a function over time or over the independent variable on which the quantity depends. Calculus is the branch of mathematics used to analyze the change of any quantity. If a function is represented by y is equal to f of x, then dy by dx represents the derivative of y with respect to x. Mathematically, this represents the variation of y with respect to change in x for various continuous value of x. Mathematically, in the derivative dy by dx is defined as dy by dx is equal to limit of del x is equal to into 0 y into x plus del x minus y of x by del x. Therefore, the limit of del x into 0 del y by del x. dy by dx represents the limit that the quantity del y by del x attain as del x tend to 0. The graph shows that is represented as dy by dx at a point b represent the tangent to the curve at derivative of some common function used in physics. The function y is equal to x power n, derivative dy by dx is equal to n into x power n minus 1. Some common function are given. In the first one, y is equal to x. Therefore, dy by dx is equal to 1. Y is equal to x square, dy by dx is equal to 2x. Y is equal to x cube, dy by dx is equal to 3x square. Y is equal to x power n. Therefore, dy by dx is equal to n into x power n minus 1. The function y is equal to sin x, the derivative dy by dx is equal to cos x. Y is equal to cos x, dy by dx is equal to minus sin x. Y is equal to constant, dy by dx is equal to 0. Y is equal to ab, dy by dx is equal to a into db by dx plus da by dx into b.